All right, classwork is on the chalkboard. Going to get started. We've got subtraction of polynomials, distribution of a monomial, and double distribution of a binomial and a trinomial. Take just about 3 minutes to work these 3 problems. Try to tune out the singing if you can. Gavin Brecken, there's a little children's song that we are hearing from our K-5 students. And, actually, more than the K-5 teacher, but anyway, they're serenading us as the teacher next door asked, "Can you hear my music when I'm playing it?" I was like, "Yeah, actually we can." She's like, "Okay, I'll try to be quiet and tune it down." Well, this is 2 rooms over, we can still hear it. I don't know what to do for that one. Just try to tune it out. And I mean, they're out of tune, so we can tune it.
That's bad.
Okay, I'm kidding. It's not that bad. Shh. No, don't you start singing, Gavin. It's like, that's bad if you can hear it all the way from your pan. No. Picking on you, Gavin. Yeah, that's another minute or so to be finishing. Finished. You did do all 3, right? No, I thought we were just doing the first one. All right, let's go ahead and take a look at these together. When it comes to subtraction, it's important to remember, class, that we never really subtract in algebra. We add the inverse. So when we see subtraction, it means we need to change all of the signs that are after that subtraction. Now, these don't come after subtraction. Technically, what sign is right here, class? Ununderstood positive. So as these parentheses come off, there's no need to change anything. But here, all the signs have to change, including the sign right here. Well, what sign is right there, class? Positive. So that sign changes as well. So instead of a positive 5x squared, class, I copy a negative 5x squared. Instead of a negative 2xy, and instead of a negative 9y squared, and then we combine our like terms together to get what answer, Michael?
2x squared minus 3xy plus 12y squared.
There we go. How many had the same answer as Michael on the first one? Questions from those who did not? Questions, comments?
I multiplied.
You triple distributed? All right. Did you do the same thing? Last year was you, now it's Abby. All right, let's go ahead and take a look here. This time we were distributing. So Abby, and she's like, this time I subtracted. If I don't like terms, you can't subtract. All right, so when we distributed here, Abby, 3 steps to multiplication, class. They are sign, number, letters. Just being aware of sign, number, letter, we're going to do it 1, 2, 3 times. Abby, what did you get for your answer?
Negative 12 x to the 5th y. Positive 3 x to the 3rd, or cubed, y to the cubed. Negative 18 x to the 4th, y to the 6th.
And I'm guessing you didn't get to this one because you were spending so long triple distributing on that one. Okay, I was about to say, you did a great job giving me the answer, but I'm pretty sure you didn't have it on your paper yet. All right, how many got the answer that Abby just got just now? All right, good job just now, Abby. Questions on the distribution? All right, here we've got double distribution that we need to take care of. And of course, Abby, you see the difference, and Noah, you see the difference between a subtraction between them and nothing between them, indicating the multiplication. When we double distribute here, of course, starting with the 8n, ignoring the existence of the negative n, distributing sign, number, letter thrice, Noah, what do you get?
8 and 2, 4, negative 24 and 2, positive.
Well, don't lose the n.
And positive 16 and squared and squared.
All right, and then we ignore the existence of the 8m, and now we're just distributing the negative n all the way through. Audrey? And I'll go and write the 1 just to help myself out here.
Positive 3 and squared and positive 2, negative 2,
There we go. And will they always line up really nice and neatly like this, class? Not always, though. What helps them to line up nicely? Brandon?
You can add your variable.
Well, no, that's why we want to line them up, but like this just seemed like it just lined up so beautifully. The reason is because
They all have the same.
no, they do the same letters, but they were arranged in descending order. So having things in descending order oftentimes will make that happen, but not always, right? And from here we just need to combine like terms back to Brandon. What do we get for our answer?
I got 8m to the 4th, negative 25m cubed, negative n. And then
Negative n. Does this just mean negative 25 n cubed n?
put it.
Oh, don't do that.
Yeah. And then I got positive 13m.
Did you have a negative 3 right here?
Yeah.
Yeah, so negative times negative positive should have given us a positive 19m squared n squared. So that was in your multiplication step that happened, and of course we'll finish with
Negative 2m n cubed.
All right, so again, pay attention. It's sign, number, letter. And the reason I emphasize those steps is my hope is, as you're multiplying, sign, number, letter, sign, number, letter, sign, number, letter. If you work methodically, you won't skip the sign step. It'll force you to think about, do I put a positive or do I put a negative? How many got that answer on that problem there? We already got all the ones you did correct. You guys only did 1. Okay. Questions on this at all? Any questions? All right, turn in your textbooks if you go to page 19. Page 19, I want to quickly review what we looked at yesterday, and toward the back half of the hour. And Genesis, good to have you back with us. I'm going to talk to Genesis here, but obviously all of you listening, I'm going to refresh primarily for her benefit. Genesis, you'll recall, going back to Algebra 1 a couple of years ago now, let me drag the camera over a little bit here. We talked about something called FOIL, remember? And we said that binomials that are similar to each other, they have like terms here, they're both x's, these are both nothings, okay? Similar binomials can be multiplied by something called FOIL. First, outer, inner, last. As you look at problem number 13, there on page 19, we've got a z negative 4, all of you doing it with us, times a 2z positive 3. We can FOIL. It means we multiply our first 2 terms together. We're going to multiply the outer 2 terms together, then the inner 2 terms together, but with similar binomials, the outer and inner will be like, so they will combine. We'll try to do all of that in our head, and then the last will multiply together as well. So when I multiply my first 2 terms together, Genesis, what do I get? Good, thinking sign, number, letter, 2z squared. Then the middle term is going to be both the outer and the inner. And I suppose we could write things down here. I prefer to keep track of it in my head, though. What do I get when I multiply my outer 2 terms together? A positive 3z. And the inner 2 terms? And we're going to add the negative 8z with the positive 3z. Negative 5z. And then, of course, we'll come to our last, and we'll simply multiply. Remember, common mistake is because you just added outer and inner after multiplication. I see a lot of people adding the last. Multiply sign, number, letter. Well, sign, number, in this case, the last. Genesis. Negative 12. All right, for the rest of you, questions. We remember this from yesterday. All good? And then Genesis questions on this. Been a little while since we've done anything like this. Questions. All right, just practice, I think, will get you back in the flow of this. For number 14, Genesis, we have something special that we could FOIL. I mean, these are similar to each other, but class, they're more than just similar. They're almost identical, except one's a negative, one's a positive. There's two different names for this. Maddie, what are the two different names for this thing? It's gonna be, it's not yet. Right now it's a sum and difference. You might remember calling it that. There was another name for it. Do you remember the other name for a sum and difference? It does start with a C. Conjugates. Good. These are what we call conjugates of each other. When you multiply conjugates or you multiply sum and difference, we said there were 3 steps. Square the first, square the last, put a minus sign between them. So if we were to square the first term, Genesis, we would get, if we were to square the last term, we would get, which is 25. And then we just put a, and there's the difference of squares we get when we multiply a sum and difference. Okay? And of course, that's a fact we want to memorize, right? That if you multiply a sum and difference, class, you get a difference of squares. Good. By the way, notice when you FOIL, you're always going to end up with a trinomial answer. It's just an ordinary everyday trinomial, but a trinomial answer nonetheless. Coming over to number 15. Here, Genesis, we have the quantity p plus 6 being squared. And we said that one thing we could do here is we could write it twice, right? P plus 6 squared literally means p plus 6 times p plus 6. And we could FOIL it. But remember we said when we square a binomial, there's a quicker way to get a perfect square trinomial. That's just square the first, square the last, multiply and double. So Genesis, when I square the first term, when I square the last term, and we always get a positive, remember, when we square. So positive 36. Even if this were a negative, it would still be a positive 36. And then we're going to multiply these two things together, which 6p, and we're going to double it, meaning times 2. 12p. Whatever sign we have here is the sign we would keep here, generally speaking, unless for some reason we started with a negative. But technically, if you want to think through sign, number, letter, positive times positive is positive. 1 times 6 is 6. Doubled is 12. P times no other letters is p. But there's our p squared plus 12p plus 36. And again, class, this is a special trinomial. It's called a perfect square trinomial. You get a perfect square trinomial anytime you square a binomial. Okay, when you square a binomial, you get the perfect square trinomial. And the number 16, we've got w negative 1 cubed. Now, Genesis, I did not teach the class a shortcut for cubing a binomial, though I mentioned to them that later on in the year, I'll be teaching a shortcut that will allow you to raise any binomial to any power quickly and easily, even the 8th power. And you can finish the problem doing almost no math. It's going to be great, but you have to wait till later in the year. So for now, we said a w minus 1 cubed, Noah. How might I approach a problem like this? Right, realize that cubed is merely first power times second power, right? There's still 3 of them. Because we know a shortcut to square, let's at least square what we can. And when we square the binomial, class, 3 steps?
Square the last, multiply and double.
And when I do, I'm going to get what kind of answer, class? And what is the perfect square trinomial I get when I square the first, square the last, multiply and double, Michael?
W squared minus 2w plus 1.
And of course, this w negative 1 is still sitting out here. How do you suppose I'll finish this process out now, Genesis? Double distribute, like we practiced a moment ago in the classwork. So when we go ahead and distribute Audrey, go ahead and do the initial distribution. And then when we distribute the negative 1 all the way through, Abby?
Negative 1w squared positive 2w negative 1.
And of course, we just need to combine the like terms together, Brandon, to get what answer?
W cubed, negative 3w squared, and positive 3w, negative 1.
And there's our answer there for the cubed binomial. Questions on this from the rest of you or from Genesis? Any questions at all? All right. Turn over to page, or turn back, excuse me, to page 15 now. Turn back to page 15. And on page 15, I want you to work numbers 30 to 46, the even. 30 to 46, the even on page 15. Careful with signs. Careful with your exponents. Remember when you multiply like basis, class? Add the exponents. When you raise a power to a power, multiply the exponents. And Abby's finished. Michael's finished. Gavin's finished. Kendall's not finished. We miss you, Kendall. Okay, I miss her. Okay. I'm just kidding. Audrey misses you too. We know that for sure. She said so this morning. Well, she said you weren't here. I assumed that meant she missed you. Okay, Audrey? Just another minute or so to finish up. Let's go ahead and take a look at our answers here. Number 30, what did you get for your answer, Brandon?
X to the second, negative 4.
Good, x squared minus 4 is correct. Number 32, Genesis.
X squared minus 64.
X squared negative 64 is correct. Number 34, Audrey.
9x to the 4th minus 16.
Good job. Don't forget the number. Square the number to get the 9. Also square the letter. Raise the power to the power. Multiply exponents x to the 4th minus 16. 9x to the 4th negative 16. Number 36, Noah.
4x to the fourth negative 16y squared.
Good, 4x to the fourth negative 16y squared. How many perfect on all four sets of conjugates? Sums and differences. Questions on any of those? Genesis, which one or ones did you miss?
34 and 36, I didn't square the numbers.
Okay, so you took care of the letter but forgot about the number that went with the letter. Be careful, that's why I mentioned it because I know it's a common mistake. So, good. Number 38, squaring the binomial. Michael.
X squared negative 4x positive 4.
Good, x squared negative 4x positive 4. Number 40, Maddie. Y squared positive 10, y positive 25 is correct. Number 42. What did you get, Abby?
4x squared positive 16xy positive 16y squared.
Good. 4x squared positive 16xy positive 16y squared. Number 44. Let's come back to Audrey. What did you get?
9c squared minus 102cd plus 144d squared.
Trying to figure out what you did. That is not correct, Michael.
I got 9c squared and negative 144d squared.
Ah, you did not square the first, square the last, multiply and double. You squared the first, squared the last, put a minus sign, didn't you?
Mm-hmm.
But when you square a binomial class, you've got to do what? 3 things? Square the first, square the last, multiply and double. Because anytime you square a binomial, you're going to get what kind of answer, class? Perfect square trinomial. We've got to have 3 terms in there. So help him out. Let's go back to Abby.
9c squared negative 72cd positive 144d squared.
Good. It is a positive because when we square the last, we get that positive. 9c squared negative 72cd positive 144d squared. So when we multiply, it's 3 times 12 is 36. Double that is 72. Audrey, what number did you say you had? 102. So you somehow doubled to 51. Unless you misread the 2 as a 7, because 17 times 3 is 51, times 2 would be 102. Maybe you misread the 2. I don't know. Questions on 44? Michael, did you also miss 38, 40, and 42 then?
No.
So on those you squared the first, squared the last, multiplied, and doubled. It was just 44?
Yep.
All right. Number 46 was a fun one. Let's take a look at this one together. We've got the 3x positive 2. All of that minus 4. Quantity squared, and technically this is a binomial, isn't it? And it's being squared, so class, 3 steps.
Square the first, square the last, multiply and double.
When we square the first, well, that's 3x plus 2 squared. Just like if it were an a, it'd be a squared. If it were a z, it'd be z squared. It's 3x plus 2, so it's 3x plus 2 squared. We square the last class, we get positive 16. And then we multiply and double. And remember I said focus on the number. 4 times 1 is 4, doubled is 8. Keep the sign, keep the letters. Well, the letters is this thing, the 3x positive 2. How many did this initial step here on 46? There's another way you could have done it, so it doesn't mean you're wrong. We would square the polynomial here, and we could get a 9x squared positive 12x positive 4. We could distribute the 8 to get negative 24x negative 16. And of course, we have this plus 16 at the end. Very conveniently, plus and minus 16s cancel. I can combine these 2 terms, and that'll give me a negative 12x, and I get a positive 4. How many ended up with this answer, even if you didn't do it this way? Oh, okay. Well, Audrey, good. Audrey, what way did you do it?
I took the negative 4 and the positive 2, just like negative 2 instead.
Yeah, the parentheses can come off because there's a positive in front here. And negative 2, or positive 2 and negative 4 are like terms that combined to just give us negative 2. And so we could square the first, square the last, multiply and double, and get it that way much quicker and easier. Now, that only worked because we had like terms. If this had been a, like a 3x positive 2a minus 4 all squared, you're stuck with this method, right? But because they was alike, you could do that combination step. Questions on 46. Questions on 46. Again, it was a little bit of a more interesting problem, shall we say. Questions? All right, got some more problems for you. You can set your books aside, keep your notebooks out, and let's go ahead and work some problems now on the screen. Variety of problems, some binomials to square, some sums and differences to multiply, and some similar binomials to FOIL. And Abby's done with all 6. Did she get them all right? That's the question. Pencils down even if you're not finished. Let's go and take a look at these together. The very first problem, class, what 3 things do I need to do?
Square the first, square the last, multiply and double.
Check your answer. Should have gotten 9r squared positive 24r positive 16. How many had that answer? All right. Genesis, what'd you have?
9r squared plus 24.
Okay, you just forgot to square the last. Okay. Now on the next one, should have gotten a squared b squared, not ab squared, but a squared b squared minus c squared d squared. How many got that answer for the second one? Excellent. On the next one, by the way, that was square the first, square the last, but a minus sign. Here we're back to square the first, square the last, multiply and double to get 9 minus 12y squared positive 4y to the 4th. How many had that answer for the third one? Okay, Audrey, what did you have? That's the next problem. How about the problem right before that one? Or did you just skip the third one altogether? All right, that explains it. On the next one, when we square the first, of course, that's, as Audrey just said, 4x to the 8th. When we square the last, 0.5 squared. Ignore the point for a minute. What's 5 squared? 25. But there is that decimal point, right? 1 decimal place. And when you square, you're going to multiply 1 decimal place by another decimal place. How many decimal places in the number? 2. 1, 2, she'll get 0.25. The other option is treat 0.5 as a half, square it 1/4 when you square, which is 0.25. Of course, we always get a positive. Then we've got to multiply and double. 0.5, think a half, 0.5 times 2, 1/2 of 2. 1, then double it, 2. We're going to keep the sign, which is the negative. We're going to keep the x to the 4th. How many got either this or maybe at a plus 1/4 instead of the 0.25? Okay, good. Several of you handled it well. Middle row, questions? Questions?
No questions. I just managed to take the 2x4, and do the b cubed for the second equation, and I mixed both of them.
All right.
So I got
Don't tell me you did the same thing. Okay.
I somehow had another 3 instead of the number 2. So like
Right here.
Yeah.
All right. Okay.
I just wasn't that working. But I got the 4x to
All right. Looking at the next one, this is not a difference of sum and difference. It's certainly not a binomial squared. What do we do to multiply right here, class? Not backwards. Foil. They're similar binomials. We have a squares in the first spots. We have b cubes in the second spot. Just foil them. When you multiply the first, should have gotten a 6a to the 4th. When you multiply the outers, that's a negative 4a squared b cubed. But I'm just going to remember negative 4. The inner is a negative 3. So negative 4, negative 3, negative 7. And again, the letters are a squared and b cubed. And then we multiply the last sign, number, letter positive to b to the 6th because you're adding the exponents there. And we got this answer. 6a to the 4th, negative 7a squared b cubed, positive 2b to the 6th. Questions, middle row.
As I said, I just mixed those two together.
Twice?
No,
Oh, you only worked one problem. You
I
pushed
worked
this
one
into
problem.
one problem. So instead of
Yeah.
having 6 done on your paper, you have 5.
Yeah.
Gotcha.
I had a positive x.
Right here. Okay, so you're probably thinking 4 and negative 3, but it is, as you see, a negative 4 outer, right? So that's probably where the mistake happened. Genesis? Didn't get to that one. Questions on it? All right, looking at the last one here, squaring the binomial. But we've got literal exponents this time. Oh, well, still square the first square, the last multiply and double. What do you get when you square a to the n, Noah? A to the 2n. Because remember, when you raise a power to a power, just multiply the exponents. So the n and the 2 get multiplied 2n. For that matter, when you square the last, what are you going to get here? Maddie?
2.
When we square the last, what do we get?
B to the 2m.
A positive b to the 2m. And then we need to multiply and double. Of course, looking at our numbers, that's 1 times 1 class. 1 doubled 2. Keep the sign. Positive. Keep the letters. And there we go. A to the 2n plus 2a to the n, b to the m, plus b to the 2m. How many had this for the last one? Good, several of you. Questions from those who did not? Questions? Got just a few more for you. And the nice thing about these, you should be able to look at the problem, do all the work in your head, and just write answers. All right, pencils down. Even if you're not finished, let's take a look at these. The first one is what special case, class? Conjugates, or sum of difference. When we multiply, we're going to get a difference of squares. And the difference of squares should be, square the first square, less put a minus sign, 25a squared minus b squared. On the next one, we have what, class? Similar binomials, so we're going to FOIL, as Abby said. First, outer, inner, last, 4x squared, that's an 18 and a 2 is 20x, positive 9. 4x squared, positive 20x, positive 9. The next one, what special case? Conjugates again, sum and difference. Square the first, square the last, put a minus sign. 81m to the 6th, negative 64n to the 8th. Should have been our answer. Remember, when you raise power to a power, multiply the exponents. The next problem, once again, class. FOIL, similar binomials. We're just going to FOIL here. First, outer, inner, last. Let's see, that's a 3x to the 4th. Outer is a negative 5, inner is a positive 9, so that's positive 4x squared y. And the last is a negative 15, y squared. And then our very last problem, class, is obviously a binomial squared. It's a big one, yes. It's a binomial squared. And when you square a binomial, you get a perfect square trinomial. When you do what three things? And when you square the first, you get a 9x to the 10th, y to the 4th. Jump to the end, you square the last, that should be a positive 4a to the 2n, z to the 6th. And when you multiply and double, it's going to be a negative 12, a to the n, x to the 5th, y squared, z cubed. Keep those letters in alphabetical order. Did anyone go 5 for 5? How about 4 for 5? 3 for 5. All right. Questions on the one or ones we missed? Any questions at all? Going once on questions, twice on questions. Gone on questions. Clear desk except for a blank sheet of paper and a pencil. One clean sheet of paper and a pencil. Everything else away. Clean sheet of paper and a pencil. Everything else away. First and last name at the top of your paper along with today's date, which is 8/19/21.
Yes.
That sound good? Let's agree on that. 8/19/21. If it's not, it at least identifies as 8/19/21 today, so we'll respect that. 8/19/21 is today's date. Getting political there, gotta stop that. First and last name, 8/19/21. This is quiz 2. Quiz 2. As before, please do not write on the quiz copy. Merely use it as a cover sheet to all of your work on your own paper. Oh, you need one more? Well, you don't. Abby does. All right. Let's go and take a look at the quiz together very quickly. Numbers 1 through 4, write the answers. Numbers 5 and 6, simplify, combine like terms. Numbers 7 through 12, multiply. And all of these are methods that should involve, well, other than number 12. Number 12 will require some work on paper, but other than that one, should be able to do the work in your head. All right, go ahead and get started and use that quiz copy as a cover sheet. I'm going to write the homework on the chalkboard for those who are watching on YouTube, and so you can pause the video here after this, and I'll end the video after I've written the homework.